Make sure you go see them before they shut down. Also, registration is going to close down after this talk, so if you want to get some shirts, make sure to get them now or after the talk. Also, make sure to see all the vendors and sponsors. Media Archives is selling videotapes of all the presentations, $10 for an individual talk and $40 for both days, all talks, all of LayerOne 2014. We have Ghostwood with You've Been DDoSed. It's not a joke anymore. And big round of applause for him.
Thanks everyone. I realized that I'm the only thing between you and a party, so I will try to be quick and let you out about 5 minutes earlier. Anyway, kidding. Okay, let's see. Give me just a second, because computers are hard, apparently. Okay, it worked. Cool. Okay, so quick intro. Over the past, I don't know, 6-7 years, I have worked for several fairly large companies. Most of my work was focused on dealing with edge infrastructure and security, as well as DDoS mitigation in some of the cases. Currently, I work for the professional services organization of a fairly large company, and part of my duties is to work with customers on improving their infrastructure to increase their resilience to denial of service. So this is the third talk on this topic I'm giving at LayerOne, and it's kind of interesting to see how things have progressed over the years. Initially, we were looking at certain type of attacks, then things kind of shifted a little. So I'll cover a bit of that, but I was looking at some of my old slides. And it was really interesting to see how the focus is shifting every year, but the whole theme is kind of still the same. So anyway, so the usual disclaimer: the opinions expressed in this presentation are mine and not of my employer, which is a major vendor, hardware vendor, which actually does not have DDoS mitigation gear. So we really have no horse in this race. And also, if you have problems understanding me, if I'm speaking too fast, let me know. If you do not understand my accent, tough luck. Can't change that. So anyway, if you have any questions, don't hesitate to interrupt me. Let's make this interactive. I'm actually not used to speaking in front of a large audience. I'm always working with people, and it's very interactive. So I'm not that good of a presenter. So what am I going to cover? How things have kind of changed over the last year. Specifically look at what the reflected in DNS and NTP attacks are, and where I think things will be going next in the probably the next 3 to maximum 6 months actually. So that's what that's what we're going to cover. Now, the DDoS landscape over the past year, what has changed? So bandwidth has changed a little, motivation pretty much stayed the same. Tools and technologies also kind of shifted a little. Now people are using NTP instead of using DNS for the major volumetric attacks. So that's kind of where things are nowadays. Now, from point of view of motivation, probably you have noticed that there's much less talk about anonymous. But if you look at what's happening in reality, we still have the same, the same targets: banks, large corporations. So even though there's not a lot of public talk about anonymous, the same stuff is going on, and we pretty much have the same actors behind it. They're just branded in a different way, and they're not that vocal about themselves and using particular names. Looking at bandwidth, this is kind of interesting. Last year there was a fairly large attack that was kind of concerning because it was a big gap from the years before that. Now this year is not as bad, but let's take a look at this. So based on the Arbor Networks report from 2010, there was one attack that was about 100 gig. And now looking at how things changed over the next 2 years, last year we had about 300 gig, and this year we had Cloudflare report a particular number. Do you remember that number? 400, yes. So how realistic this number is, I don't know. There's a lot of controversy around this number, and if Cloudflare, are misreporting or not properly measuring it, so I can't comment on that. But the number that they were reported is 400 gig. So you can see kind of where things are going. Some of the limiting factors are still the fact that no matter how large of a botnet you have or how many reflectors you have, you still cannot manage to deliver certain amount of traffic to an endpoint just because the connectivity of this endpoint is somewhat limited. Now we're talking about limited in the tens of gigabits, but still it is somewhat limited. Now what is contributing, on the other hand, to being able to produce attacks that are somewhat large? So over the last couple of years, if I have to generalize it, is the availability of reflectors and the ability to amplify traffic. So those are two particular components that I would kind of like to look into, because they're common for the DNS amplification, NTP amplification, and SNMP, which is going to be coming in the next 3 to 6 months. So look at the two concepts, reflection and amplification. Looking at reflection, okay, let's see. Yes, this is the lightsaber. Let's see, how do I turn this thing on? Good. So we have the attacker. The attacker is sending a packet with a source IP address, which is not their own IP address. It is actually the IP address of the victim. And when it hits the reflector responds to what it thinks is the source, which actually is the victim. Now add to this a number of reflectors, and you can see how this can scale up. So what does reflection do to help you? Why is it used? Okay, so that's the amplification factor. So the two answers that I heard is, one of them was obfuscates the source, and the other one is amplifies the attack. So in this particular case, we're only obfuscating the source of the attack. But you're right, the next point will be amplifying it. So why is this so important? Why is it so important for somebody to obfuscate? Okay, so you don't go after them, but if they're coming from a geography where the US legal system doesn't have reach, there's not much help in that. So one of the issues is that with stateful protocols, when you have to have a real IP address that is talking to you, you can always block that. You can have some system that can automatically pick up traffic that is abnormal. They can block this source. With stateless attacks, as DNS and NTP are, when the source is changed, it is going to be fairly difficult to do this filtering. Now, keep that in mind, that this is more around this victim here, because they'll be seeing the reflector in this case, but they will never be seeing the attacker. Now, also the reflector itself, if they decide to do something about the problem, they will never be seeing the attacker IP address, they will only be seeing the victim IP address. So neither the victim nor the attacker, the reflector, can do anything based on the source IP address. Now, what was my thought here? Yeah, so I was kind of mentioning about stateless and stateful. So I kind of jumped a little, but all of those attacks are over UDP. It is a protocol that lays on top of UDP, which allows for IP spoofing. Is there anybody actually that has a question about this? I think that's a fairly simple concept. I don't need to go into that. Okay, cool. So this is the reflection part of the attack. So we have attacker, we have reflectors, we have victim. Now the next thing we do, and actually there's a little more narrative around this. Now what's also interesting here is that the reflectors usually are unaware of what's happening, and they're unwilling participant in this attack. Now, that while having that in mind, it still is not going to look good if you are participating as a reflector in an attack and a significant portion of the attack is delivered from your DNS infrastructure. Let's say if we're talking about reflected DNS. you never know when this will come out in the newspapers, especially if the victim is a competitor of yours and somebody on the victim network does not properly investigate the incident and just sees a fairly high amount of traffic coming from your IP space to their web server or to their DNS infrastructure. So you got to be careful there because, you know, some people say, oh, it's not my problem, but actually it is your problem because first it's, in general, it's about internet hygiene and all of us have to kind of live together on the internet. The other thing is that there's also certain liability depending on the IP space that it's used, and also maybe the attacker has some other agenda behind all this. Maybe they're masking actual intrusion traffic that is going, and maybe that's why they're picking particular reflectors. So you have to be careful about that. Now the second component, okay. I obviously am not paying attention to the slides. So the reflector types, so the protocols I mentioned so far, DNS, NTP, and SNMP. So there are other protocols that can be used to do reflection, but those three I have picked intentionally. And the reason I did so is because they allow for amplification, which was the second point that was brought a second ago. What does amplification mean? That, let's say in the case of a DNS, we'll just have a small query going to a reflector server, and then the reflector will respond with 512 bytes or more, depending on the protocol. For example, if they're exploiting some of the DNSSEC records, they can have much bigger responses. eDNS0 as well allows for much bigger responses. So here you're looking at, in the best case, you know, 8 times amplification. Sorry, that is the least efficient case. So that's the best case for the victim, but you know, it could be much worse than that. So we have that in DNS, NTP, and SNMP as well. Now, why would somebody want to have an SNMP server exposed to the internet? That's another question, but definitely something they need to look at. So those are the different types, you know, different protocols that provide fairly high ratio of amplification. Now, if somebody would like to only conceal the source of their attack, they can easily use Chargen, or they can even do some form of SymFlood, which is only going to provide reflection, but not really amplification. That, you know, if they just want to anonymize it, why not? Okay, so quickly, let's look at how the DNS infrastructure operates and how the attack would work. And I have more detailed slides if you would like me to go into details, but just in few words, we have a user workstation which talks to a recursive resolver, usually on premises in the company or on the corporate network. And then this recursive resolver is going to go to the internet and ask the necessary servers working up the chain of the DNS name to figure out what the IP address is, and or if it's a PTR query, then it will be the other way around, IP to name and so on. So now, if you notice, this server is designed to service this client only. So whatever this client asks, this server will go and work on it and respond. Now, if there was an attacker somewhere over here, and if they're asking that server a question, there's really no legitimate reason for, you know, for this server to be answering somebody on the internet when this server is designed to service this corporation. Well, that's kind of obvious, but not too many people that configure DNS servers on the internet. So we end up with servers that would respond to random queries from the outside. Now, if this query here has the source IP address of a server here, the query will come here, and this guy will respond to this victim as if it was the actual machine that made the query. And as I explained earlier, you see how the reflection works and how the amplification will send more traffic. Now have more resolvers, more reflectors, and we have a problem for the victim. NTP is kind of similar. So what's interesting around NTP is that, you know, we have the same thing. User talking to an NTP server. The NTP server will go on the internet, fetch the time from other NTP servers, and report back. Now, In NTP, there's the notion of different stratum of servers. So the ones that are stratum 1 are connected directly to a GPS unit and are reading, or some other high precision clock, and are the sources of this information. So if you have one of those, if this is one of those, that would not be a problem, but most people run an NTP server on their network that goes and talks to higher stratum servers. And this is what the problem is. Now, many years ago, for some reason, maybe for debugging purposes, maybe somebody, I have no idea really why they did that, but there was a command developed called monlist that when issued from a user to the NTP server would respond with a list of all clients that ever talked to it, up to 600. So think about it this way. I'm sending a single query and then I get a large list up to 600 entries of servers that have talked to this NTP server. How is that useful? Apart from denial of service, I have no idea. But the way it is used for denial of service would be somebody here on the internet, an attacker would send a query to the NTP server requesting monlist, and then would spoof, let's say if there's a, let's say a target here, they would spoof the query with the source IP of the victim, would request the query to the NTP server will respond with all the traffic going to the victim. So that's amplification, and then that's reflecting and amplification, and then add a large number of NTP servers, and we have large amount of traffic going to that victim. Now the next one that is coming, and like a couple of weeks ago, I was already looking at some tools that a friend of mine got from some underground sites. They were basically looking at doing SNMP, using particular SNMP queries. I'm not going to go into particular details, but this will be out soon. We'll be seeing those soon. There's already a lot of scanning on the internet for open SNMP servers. Some of those are researchers. Actually, funnily enough, most of those are researchers. But again, this infrastructure is already well mapped. Actually, when the DNS attacks started coming out, I could see the NTP and SNMP scanning was already going. So the people that know what they're doing just decided to save SNMP for later, and this is why NTP was used at this stage. Yeah, I'm thinking another 3 to 6 months we're going to start seeing SNMP being used as amplification. Now, what can you do about it? Well, there's one thing you can do if you want to be a good internet citizen. Jared Malk from... Oh, you know what? I think this is... Okay, that's pretty bad. Yeah, that's classified. Anyway. I'll fix that slide, but if you have questions, just come to me. I'll read them now. OpenResolverProject.org and OpenNTPProject.org. It's the same guy behind them, Jared Malk from NTT. What he does is he has a machine, some fairly old machine in a colo that usually takes about 24 hours to scan the internet for each of those ports, and he provides lists of machines that responded on particular ports. For NTP that would be 1, 2, 3, DNS 53 and so on. So look at those. He publishes the lists, and if you have IP space of yours that belongs to those lists, or there's an intersection between your IP space and those lists, just go and mitigate that. There's really no reason for NTP servers to be open to the internet. DNS servers, there are certain companies that run their model around providing recursive DNS service, but unless you are Google DNS or OpenDNS or another startup that is going to do yet another DNS, you probably don't have a reason to be doing that. Also, the other thing is that there's rate limiting patches for bind. So if for some reason you need to offer this as a service, you can enable rate limiting. If you look at my talk from last year, actually I'll go into some details about the configuration of bind and how you do that. Also, it is on the ISC website, so it's literally 4-line block that defines the rate limiting. So it's fairly simple to implement. And what it would do, it would just, if a particular IP address, which actually is the victim, is repeating the same query many times a second, it would just rate limit how many times it's going to respond to it. Because there is really no legitimate reason for a client to be asking the same question multiple times, because based on the DNS protocol, there will be a TTL in the packet, and they're supposed to cache that answer for X amount of seconds. So, okay, that's a mid-session Q&A. Sam? We should probably talk later. I just don't want to talk details. There's particular records that you can request X amount of times.
Walking through what I thought was everything. SNMP walk doesn't get it all?
So SNMP walks in a different way. SNMP walk is going to go through different MIBs, through the different through the different OIDs in a MIB. It does bulk queries and does multiple, but it is not as. We'll talk in details after that. I just don't want to talk too much about it because it's still not widely public, and it's something that's going to be weaponized fairly soon. And I'd rather not be the one spilling the beans. Questions so far? Okay. Okay, so what did not change over the past year? So pretty much the business side did not really change. The need for partnerships did not change, especially when you have IP addresses, the source IP address obfuscated or spoofed. You really need to be able to quickly talk to your upstreams, and they need to be able to talk to their different upstreams in order to trace the traffic, because at this point they're not looking at IP flows and so on. They're looking at counter zone interfaces. Here and there they can look at flows, but all pretty much needs to happen real time, because you're under attack. Somebody's under attack. Somebody is down at that point. So the better your level of, or the higher level of partnership you have with your peers, the better for everybody, because you can trace the attack back to the origins. Also, there are particular groups that actively work to remove or depeer certain providers that do not implement egress filtering. There's particular co-location in the Netherlands that is well known for hosting a lot of malicious activity, and they intentionally do not apply any egress filtering. So a lot of the reflective attacks are actually launched from there because they have really good connectivity, and with 1 gigabit interface on a system, you can cause a lot of damage using reflection. So let's say that one of their peers dropped them about a couple of months ago, and there's more coming. And this is again based on some community efforts. Because when certain operators decide to monetize on being malicious, this is bad for business for everyone, because this is excessive amounts of bandwidth used. That means that their customers are not happy and so on. So people tend to get upset. But again, it takes time to build the case. It takes time to collect the logs. And if you do not have those partners ready to work, preserve logs while the legal process catches up, it's just not going to work. Okay, the business side of it. So let's look at it in a slightly different way. How does a DDoS is different? How is a DDoS different from CNN pointing to your homepage? So it's pretty much a matter of the ability to serve traffic fast, be it through having larger pipes and more bandwidth to the internet, or having your systems positioned in such a way that they're in a place where you can upgrade it, or you can have access to more bandwidth. So here I'm talking specifically about companies that like to host physically on premises versus hosting in a co-location. And I have seen many of those, and you won't actually believe how many large enterprises for some reason still want to host on-site versus buying rack space somewhere outside of the company. And again, also, you know, if it is some kind of stateful attack against the web servers, how's that different from many customers suddenly starting to click on links going to your website? It's not very different. So it's all about capacity that you have provisioned, and the ability to absorb a DDoS is pretty much the equivalent of being able to serve more users at peak times. I remember many years ago, I was I was living in a place where they had realized that it's actually cheaper to be down for 5 minutes on the top of New Year's, because they knew that everybody will be calling everybody on top of New Year to say Happy New Year. And they would just shut down the phone switches. We're talking about 25 years ago, but they would just shut down the phone switches so that the phone switches don't go on fire, and literally on fire. So, you know, that was their mitigation to the denial of service. You know, if this is not acceptable to you, then you may want to consider how to increase your resources so that you can handle these kind of situations. Or maybe for some businesses, it is not that big of a deal. I've worked with a couple of hospitals that have no critical public-facing infrastructure. So they're like, well, if the site goes down, yeah, that's bad for the image, but yeah, the customers will not be able to schedule online appointments, and they're going to call the call center, and they're still going to complete the business fine. It's not a problem for us to be down for 10 minutes or 20 minutes. So it's a matter of, you know, of the business deciding to what level they would like to be able to take abuse and be up. And another way also to position this to management is that denial of service condition that impairs your infrastructure, and I'm repeating, one that impairs your infrastructure, because you can have a denial of service and you can still be serving through that, but denial of service that impairs your infrastructure is pretty much equivalent to an outage. So if you have to talk to the IT management types, you can just position it as, hey, you know what, if you do not want to have an outage in this storage array, you buy a redundant storage array and you do replication. Same thing with DDoS. If you do not want to be suffering, you know, be down during a 10 gigabit attack, buy more bandwidth and more equipment so that you can take higher levels of attack. And they'll figure out what they want to do. It's, you know, at least you warn them. And at that point, it's a business decision. And that's pretty much actually what I was trying to explain a second ago. You have, you know, mitigation is kind of like insurance. You invest certain amount of money, and you know that you're protected up to a certain level. Now, speaking about being protected to a certain level, if we look at this diagram, so if we have the intensity of the attacks in this direction and the number of attackers that can potentially cause certain intensity of attack, or the number of attacks, you will notice that there's a large amount of attackers that can do small attacks, and there's only a few attackers that can do really serious damage. So the entire risk mitigation is basically this, figuring with the business where this bar should be. If it should be low or it should be high. How far the bar goes depends on how much resources you throw into it or how much money you throw into it. It's pretty simple. It's a business problem, not really a technical problem. Okay, another Q&A session. Let's see. Oh, 3 people are still awake. That's good. Ah.
Future on with DDoS defense or retaliation?
Okay, that's a good question. Answered in the last line on my slide. Talk to the professionals. So that's part of the subtitle of my talk. It's not a joke anymore. So until about 4 or 5 years ago, I would advise most people to, or most large companies, to just mitigate themselves. And this was at the time where I was suggesting that they work on 20 to 40 gigabit connectivity and having sufficient server capacity to handle that. And there was not much more than that. I mean, there was like the 100 gigabit attack that a particular government institution received, but there was not much. I think there was another one that was about 60, and then everything else was about 10 to 20 gigabits. Nowadays, we're looking at fairly high values of attack. So if we go back to the pyramid here, we can actually define a second line. So the first line is maybe here will be how much you would like to be able to mitigate on-site or on your own infrastructure. And then the next line will be how much you would like to mitigate through a scrubbing provider. So the delta here is the expense that you are going to be incurring between your mitigating on your infrastructure and paying to an expensive provider to do that for you. So you know, that's again business problem, but you define those two boundaries. You say, hey, you know what, I want to do up to 10 gigabits on site. If it is more than 10 gigabits, I inject routes, send them to, you know, sorry, I have Prolexic inject the routes, take my traffic, scrub it, then send it to me. That's pretty much it. But that's on the side of, let's say, on the brute force side, on the side of actually mitigating the traffic. Over the last 5-6 years, there has been a kind of a new discipline or new brand, if you say new buzzword, called threat intelligence, which is about researching threat actors, researching the technologies. And this is another type of answer to your question. A lot of the companies are currently working on being able to identify the actors, attribute the attacks, and prosecute. And this is happening more and more. About 7-8 years ago, it was unheard of for somebody to go and prosecute people for executing a denial of service. Or for any other online crimes. This was extremely rare. Now there's more and more work in this area. Larger corporations are creating entire departments that deal with attribution and passing information to law enforcement to execute the arrest. And you know, they follow proper process so that everything stands in court and so on. So this is another side of the question. Now, another area is also, and it is kind of tied with threat intelligence, is dealing with the sources of the attacks. So be it drones or reflectors, you have to have machines on the internet that are going to send the traffic to attack the victim. So instead of blocking everything on the victim side, let's say if we have the victim here, and this is the periphery with all the different clients, instead of blocking the attack right before the victim, you can actually block at the output points of the reflectors or the output points of the bots. This is also becoming component of the mitigation strategy, but it's never going to be 100% efficient because there is a very large amount of IP space that is not controlled by corporate entities that have alignment and desire to deal with those problems. I'd say there will be a lot of nation states or other countries that would not care about it, and traffic will be coming from there. And we also, for political reasons, do not want to disconnect certain countries from the internet. So there will be still some traffic coming, but there will be other mitigation techniques there, as I said initially, you know, having beefier hardware and so on. So there is no specific type, because if the entity is down, it's down. Doesn't matter if it was a ping flood or a SIM flood or reflected DNS. But the ones that are prevalent and appear to be fairly easy to execute nowadays are DNS reflection and NTP reflection from point of view of denial of service. So I would say that would be the two that are currently the trend. Though a SYN attack, if executed properly, is just as effective. Other questions? Okay, mitigation. So kind of few categories here. So you can defend yourself, and we already covered this, right? So I'll kind of run through it. You can defend yourself. There are different technologies. For example, if you are defending DNS and if you have large infrastructure, you can employ Anycast, where you have multiple physical servers answering queries to the same IP address. And those servers are distributed usually in different geographies with separate connectivity. So there's a high level of redundancy there. The other one is DDoS mitigation gear. There's particular vendors that are focusing solely on that. the worst one that I have seen overlooked many times is the overall network architecture. So if you think that a firewall can be put in front of your web servers and it will stop the bad guys, yes, it will stop the bad guys. It will stop everybody from accessing your website because the firewall will be the first thing that is going to burn down when there's a denial of service. So, you know, it's kind of like which computer is secure or the one that is unplugged. But what good does it do for you? Well, let's say unplugged and bolted to the floor. So a lot of the older type of architectures that were pushed by particular hardware vendors were including firewalls that are fairly close to the edge, and that just doesn't work. That doesn't scale. Now, also, if you think about it, long before Checkpoint started selling firewalls, which was the first device that was a single device that was called firewall, there were still firewalls. And definition for a firewall is a set of measures that separate one network from another. It does not need to be one single box or one single point of failure. So think of it in this way. You can start layering the defense in the furthest further out in the perimeter. You can just do stateless access lists that only allow certain ports. Then after that, you do that you can deploy some mitigation equipment. Then after the mitigation equipment, you can have front ends that are completely stateless with no data on them. Then after the front ends, for example, you can deploy a firewall that is going to do some more stateful inspection, or you may not deploy a firewall device. You may do something else. You may, have middle tier that is going to do brokering of connections between different systems, and then only the systems that are important to you can firewall off for some reason. But if you think of it, a firewall is nothing more than a glorified proxy. You can have a proxy that can do inspection of the traffic, and like the WAFs usually are. So don't basically understand what you're doing when you're architecting the network. Just don't buy a firewall and throw it in front of everything, thinking that it will help you, because it won't. Now, the second category is defend the internet. So that is becoming more and more important over the past couple of years with the proliferation of reflected DNS and NTP, because the core of the problem is actually all of those reflectors. And if you do not want to be a good internet citizen and patch yours, then there will be still a lot of reflectors that will be used for attacks. So at this point, it is about protecting the internet from ourselves, because we become part of those, of this infrastructure that is used for attacks. In particular, BCP38 is one of the earliest attempts to describe how filtering should work. But if you have to summarize it very simply, if you have stub networks or networks with only one connection to the internet, let's say your DMZs and so on, there is no reason for them to be originating traffic with IP space, with IP addresses that do not belong to you. There's really no reason for that. So have that implemented. It's not many lines of access lists. It's actually fairly small. And this is going to at least prevent you from being one of the reflectors. Also, when you're talking to colleagues from other companies, encourage them to do so. Because, here in the US, we have a lot of connectivity, and we are making much better reflectors than, a machine somewhere in a machine shop in China. It's just, we just have more ability to damage or be used to cause more damage to others. And again, talk to the professionals. Now the attacks are becoming large enough so that it's not really reasonable for somebody to invest the amount of money to be able to mitigate those. BCP38, Paul Ferguson, at the time, actually he was working for Cisco when he wrote it. Now he works for a small threat intelligence company, speaking again of threat intelligence. And those are the documents that you may start looking at, but there's also a lot more on the internet. And I have a slide out of order. That is not good, because it was supposed to go this way. No, actually, no, that's fine. So to defend yourself, Anycast for DNS, DDoS mitigation equipment. To defend the internet, there are all those smaller things that you can do. There are more of them, but they are very cheap to implement. Rate limiting, outbound filtering, properly configure your DNS servers. So the first two cost a lot of money. The the DDoS mitigation devices cost a lot of money. Being able to run Anycast infrastructure costs a lot of money as well. The other ones are fairly cheap, so why not go with them? Again, it requires that everybody will actually fix their infrastructure, but drop by drop it will turn into an ocean. And I kind of already covered that. So it's all about cooperation. It's all about being good internet citizen, and companies have to start looking at what damage they can potentially cause to the internet or other participants versus only looking at what can hurt them. Okay, let's see what else we have. Yes, so I just don't want to go too much into the hardware side. When you're working, if you decide that you want to mitigate on site, there's a number of vendors you can talk to. The most important thing is to look at packet rates. Many of them would advertise bandwidth. Bandwidth is really not important when you're dealing with denial of service. It's usually the packet rates that kill you. Partnerships, there's several fairly open groups like Team Camry, Shadow Server, and the HoneyNet project. They publish and they a lot of advisories, and they also share a lot of information. Look at the first three in particular. They're open and they're cross-industry. Shadow Server and Camry in particular. Now the different ISACs, there's different groups for the financial industry, and they're kind of more vertically oriented. So if you have an ISAC that services your industry, get involved with it. There's REN ISAC for the educational network. There's FS ISAC for financial, and there's a lot of other groups that are focusing on particular area. There's SCADA. And again, partnership. Just build partners, build partnerships. Go to conferences, talk to people. Being able to meet people in person and talk to them goes very, very long way when you need them to do something for you in the future. It just it's one thing to receive an email from somebody you never heard of and asking you to do something that is kind of questionable or can kind of influence your network in a negative way. It's another thing if you have already talked to the person, know that the person is technically savvy and they know what they're asking, and there's a reason for them to be asking that. So as I said, meeting people in person and discussing those topics beforehand, before things go bad, is really invaluable. And that's pretty much it. Hey, there's still a few people awake. Oh, they just walked into the room. That's why they're awake. Okay. Cool. Questions? Sorry? Okay, cool. Just a quick sales pitch. Thank you. I also run a small conference called Baythreat in Northern California, in the Bay Area. So if you happen to be there in early December, stop by. Thank you, guys.